Hello and welcome, everybody. Thank you so much for signing up and taking part in our talk about embodied carbon policy meets practice. This is being sponsored by the Sustainability Education Knowledge Committee with the BSA. And I'm Jessica Waters. I'm one of the co-chairs, the new co-chairs of this committee, along with Harshika Bishit. I'm going to pass this off to Sadaf and Juhi, who are both part of the CLF Boston Leadership Forum.
Thank you, Jessica. Hello, everyone. Thank you for joining us today. I just want to start by introducing our presentation today. We're talking about embodied carbon policy meets practice. And like Jessica said, this is hosted jointly between the BSA's Sustainability Education NOCO and CLF Boston. You'll hear more about CLF today, but I just want to briefly introduce myself. My name is Juhi Goel, and I am a Education Working Group co-chair of CLF Boston. I'm also joined on this call by my co-chairs Sadaf Jafari and Anna Mezheritskaya, who will be helping facilitate today. So just a few quick notes before we dive in. Please continue to keep yourself muted over this presentation. If you have any questions, feel free to throw them in the chat. Our speaker team will try their best to answer them, or we'll pick them up towards the end with a short Q&A. And lastly, we will have this presentation recorded, and slides should be available for everyone shortly after. So with that, I am going to, welcome our speaker team. Can you all still see this? Just checking.
Yes.
Okay, great. Awesome. So we have a great panel of embodied carbon experts today, sharing their knowledge in 3 umbrella areas over our presentation. We'll hear about local policy, resources and tools with embodied carbon, as well as some reduction strategies in structure and reuse. And so what that means for our agenda is we're just going to kick off with a brief section that introduces Boston's new net zero carbon policy. That will be covered by Harshika Bisht. And we will then move on to the 3-part series and end with a brief Q&A. So without further ado, let's dive in. Harshika, feel free to take it away.
Sure. Good afternoon, everyone. Thank you for being here today. My name is Harshika. I'm part of the City of Boston's Planning Department, but I'm also here at the capacity as the co-chair for Sustainability Education Knowledge Community. As you all know, Boston has a bold commitment towards carbon neutrality by 2050, and to get there, we need to start addressing these emissions across the full building life cycle. Not just what's used to operate buildings, but rather what's also used to build them. And that's where embodied carbon comes into play. We already have like a global graph that shows the slice of embodied carbon across emissions in our sector. But until recently, at least in Boston, most policies focused on the operational emissions. And as our buildings are becoming more efficient, we want to make sure we're also targeting embodied carbon, which is emissions from materials, and it's increasingly a significant portion of the climate impact of our building stock here. And that's why Boston's new net zero carbon zoning, which is going into effect on July 1st, includes a reporting requirement for all large development projects, and especially for the structure and enclosure portion. And this is a deliberate first step. The goal is to not only begin reducing these emissions, but to also build awareness across our industry, support education, and most importantly, to start collecting data so we can make informed decisions moving forward. And by embedding embodied carbon reporting and zoning, we're sending a clear signal that materials choices matter, and we want to create the foundation for a more transparent and data-driven policy here in the city. The guidance on how you conduct the LCA, et cetera, and all the documentation behind it is something the city is still vetting and will be shared before July 1st. And it was made in collaboration with CLF here, and some of these amazing speakers were part of the working group that the city had. So we want to really thank them for their contribution. And today's event is a perfect example of how we turned policy into practice. And I want to thank the BSA committee and also CLF Boston to help prepare the community for what's coming next. I'll pass it off to Brian to talk about the policies around this.
Thanks, Harshika. Yeah, hi everyone. My name is Brian Sanford. I'm an architect at Studio architects here at ENJP and one of the co-chairs of the CLS policy subgroup. So yeah, but we're going to get into, of course, the sort of regulatory, the new regulations on embodied carbon. But on the next slide here, we wanted to just kind of give some context around overall, energy and net zero carbon policies around the region. You can see here a few from Boston, Cambridge, and Newton, all targeting either new construction or existing buildings. As Harshik has said, these were really enacted as zoning, first off, and really almost all of them here are targeting operational emissions. That was the kind of first wave of regulation we saw. There's some small differences here in terms of scope and method of compliance, but overall the goals are really similar. And these are great. I think, this has been great steps that these cities have taken, including, I think we're excited about the net zero carbon zoning in Boston that, as Harshika mentioned, comes into effect next month. But I think these citywide regulations really have laid the groundwork for thinking on embodied carbon regulation. And on the next slide, we just have a quick intro to what's happening at the statewide level. So back in November, the governor signed this big climate omnibus bill. There's lots and lots of stuff in here, but most relevant for our conversation, there's the Intergovernmental Embodied Carbon Coordinating Council. It's a bit of a mouthful, but it's this big council. I know we have some members here on the call. There's folks from a bunch of different backgrounds on it, a bunch of folks from the state, both the kind of executive branch and the legislative branch, as well as some kind of professional appointees. And really what the council is working on is an embodied carbon reduction plan. This will have a whole bunch of recommendations, many of them focused on, of course, kind of state building projects and procurement and all those things the state can control directly. But also, the bill specifically calls out that the council is charged with considering how to integrate embodied carbon reduction goals into state building codes, which of course would impact every building in the state, which is really exciting. So, to be clear, this is kind of just getting going. These things will be recommendations from the council, certainly not rules enacted quite yet. But again, I think this is part of this sort of broader movement and broader trend that we're seeing that was really kicked off by local municipalities. And I'll pass to my co-chair Jane to talk about some of those local municipal embodied carbon reduction regulations.
Could we move to the next slide, please? Oh, yeah. Thank you. Hi, I'm Jane. Oh, previous slide. Sorry. Hi, I'm Jane. I'm a designer at Elkis Manfredi Architects. I'm a co-chair with Brian. And this is the embodied carbon reporting policies in Boston, Cambridge, and Newton area. If you notice, the reporting policies don't apply to small constructions. There are in Boston, it's required for construction that's larger than 50,000 square feet. So is Cambridge. And in Newton, it applies to over 20,000 square feet. So the exact deliverables per city differs, but there is some requirement of a full life cycle assessment, and depends on the city which phase you would need to report them in. Next slide, please. And this table compares, I think this would be available after this conversation for your resource. This table compares all different jurisdictions and regulations and where it would be applying to. If there is an operational emission limit, does it require some sort of embodied carbon reporting? Is there a limit to that embodied carbon, and when the effective date is? So if you see, the Boston effective date is coming up very close. It starts in July 1st. Cambridge, the requirement already started. So did Newton, and the ILFI standards remain current. So does LEED. And that is all for the local policy section.
So I am coming up next. My name is Michelle Lambert with the Carbon Leadership Forum nonprofit. And I'm going to kick off part 2, which is the Embodied Carbon 101 resources, and then hand it off to Jacob Savona, who will do an LCA tools overview. Next slide. So just very briefly, for those of you who aren't as familiar with the Carbon Leadership Forum, we are a small nonprofit organization, and our mission is to eliminate embodied carbon in buildings, materials, and infrastructure to create a just and thriving future. So our work and our research and advocacy at the Carbon Leadership Forum is laser focused on embodied carbon. We know that there are a lot of other NGOs and organizations doing a lot of amazing work in the area of operational energy reductions. And so we really fill that space of embodied carbon work. We put our work and our research and our teams into 3 different categories. The first is informing policy. We feel that policy is really, a significant lever for us to be able to drive change in embodied carbon reduction at the scale that we need to be able to meet a lot of our state and local and also, national, international climate goals. So we use a lot of our expertise in embodied carbon and life cycle assessment and EPDs to help advise and advocate for policy. We also work to improve LCA data, do a lot of work on all of the different components of environmental product declarations and product category rules and all these different pieces that go into doing life cycle assessment with really robust data and standards. And then the third bucket is that we feel that building our community really helps us to extend the reach beyond the small nonprofit organization that we are. And on the next slide, I'll just talk a little bit about our volunteer community. So the Carbon Leadership Forum has a whole network of what we call our regional hubs, which are essentially volunteer chapters of the Carbon Leadership Forum. We have 26 different hubs now in North America, and then a few others internationally. And like I said, all of these hubs are entirely volunteer-led. You heard a little bit about the Boston Northeast Hub, which you can see the blue star on the map. We are one of the earliest and really strongest hubs that provide a lot of resources, education, and things like this great webinar to the community. And so we really use, we leverage all of our regional hubs to really help us disseminate the work and the resources and things that we produce. Next slide. So my role today in the next very short couple of minutes is to make sure you have a sense that there are many, many resources available to start diving in, learning about embodied carbon, understanding how to do life cycle assessment, and so that you feel that there are, plenty of resources if you're brand new to this topic, or if you're really starting to nuance your LCA practice. Just wanting to make it, readily, abundantly clear that there are many resources, and there you will receive these slides, and there's links to all of these resources available. So these 4 are what I would consider Embodied Carbon 101. So if you're brand new to this topic, you start on the left. We have an Embodied Carbon 101 fact sheet, which is a really concise explanation of what embodied carbon is, why it's important, and what some of the considerations are to reduce it. The second one is a pre-recorded 5-video series that helps to go even a little bit further and build on some more foundational knowledge on life cycle assessment, environmental product declarations, and some other topics. The next one over is we have a whole toolkit designed for architects that we did in collaboration with the AIA. It's a 3-part PDF resource, specifically targeting the work of architects and designers and all of the ways that you can reduce embodied carbon in design, in specifications. And then the last one is an embodied carbon toolkit for building owners. This was really designed for building owners to understand the importance from their, perspective and their sort of, control of the project to be able to make some goal setting for embodied carbon. Next slide. These resources are Life Cycle Assessment 101. So again, we have a very concise building fact sheet, how to do a life cycle assessment, what some of the methodologies are. And then we also have in the middle a life cycle assessment practice guide, a longer step-by-step practice manual, essentially, for how to do an LCA. And then the third one is a 101 fact sheet on environmental product declarations. Next slide. These are what I would consider really good embodied carbon resources for practice. Our CLF publishes material baselines every 2 years, and we just released our 2025 material baselines report earlier this week. Looking at all of the different EPD values for a whole bunch of different material categories in North America. The middle is a buildings benchmark report. We also just released this amazing resource of over 200 buildings and what their total embodied carbon are, so that you can start to understand what a reasonable benchmark is for your building project. And excuse me, the third one is some model embodied carbon specifications that we have published for free on our website, open access, that you can download and use on your project. Next slide. And then just very quickly, we have a brand new compilation of 13 project case studies. If you're looking for project examples from a whole different range of sizes and types of projects, to really understand what their process was and how they were successful. All of these projects submitted their LCAs to us for review and demonstrated embodied carbon reductions. So again, another fantastic resource for some really good inspiration and examples. Next slide. And these are just, all of the different categories, just demonstrating that, there are many, many different ways that you can reduce embodied carbon on your project. Everything from low carbon concrete to looking at your, reducing interior finishes or adaptive reuse. Next slide. And then the last resource I wanted to point to is that the CLF Boston Northeast Hub during COVID actually produced a whole series of recorded webinars that are on the BSA's website at that link. And you can see, many, many different topics from many of the experts that we have in our region. And each of these is, I believe, a full hour recorded webinar on all of these different topics. So another phenomenal resource for digging into specific areas. And next slide, I think, is the last one. So how can you stay up to date? How can you get involved? There's 3 ways. You can join the CLF Boston Northeast Hub, open membership community for anyone who's interested in learning. You can see on this graphic all of the different working groups that the hub has. So if you're interested in, specifically in policy or in infrastructure or in concrete, there's a working group for you. Second is to attend, there's a joint collaboration between the Boston Hub and the New York City Hub, which is an LCA tool user group, which Jacob Savona, who is going to speak next, helps to run and facilitate. You can join that. And then finally, the CLF nonprofit has a community forum on our website where you can submit your questions to the entire CLF community and get oftentimes a lot of really fantastic detailed answers to your questions. So, make sure to check out all of those. And I think with that, I'm going to pass it over to Jacob Savona to talk about LCA tools.
Yeah, great. Thanks, Michelle. So I think before we dive a little bit deep into the available tools that are out there for everyone to use, I think it's just important to kind of understand the whole life carbon kind of overview of what we're talking about in terms of carbon emissions for our buildings. So when we talk about embodied carbon, it does kind of include each of these stages here. But a lot of tools out there, especially free tools, kind of concentrate on these A1 to A3 life cycle stages, and that specifically has to do with the products themselves and extracting, transportation, obviously manufacturing of those products. And there's kind of limited tools, or there's kind of a few tools that kind of dive into calculating the rest of the carbon emissions associated with the construction aspects, so those A4 and A5 stages, the maintenance and use life cycle stages, so that's B1 to B5, and then the end of life and beyond. life cycle stages. So understanding the demolition and of course any sort of reuse and recovery after that. What's important to point out is kind of where the operational carbon, sits in terms of these life cycle stages. So in terms of energy use and water use, those do sit in obviously the maintenance and use stages, but it's kind of, reported separately from when we talk about embodied carbon and whole building life cycle assessments. Next slide, please. So I just wanted to kind of run through some free early evaluation tools, and some of these are early, some of these can be used as a whole building LCA tool, but I'll explain that in a second. So I think the first and foremost, and I think probably the most popular one, is the EC3 tool, and this is available to pretty much anyone that has, I guess, an EC3 account. And you can use this tool to compare material-specific embodied carbon early in design using, originally specific EPD data, and you can complete what's called an A1 to A3 whole building life cycle assessment. So remember, that's just focusing on the materials themselves and not focusing on, construction plus the maintenance and use plus the end of life of the building. The next one is next couple. The Epic and Care tools are really great, kind of quick, what we call quick whole building life cycle assessment, embodied carbon estimating tools. So you can kind of put in kind of minimal inputs in order to kind of support early decisions around, around early concept designs for your projects. And so you can kind of understand maybe some early design decisions and some embodied carbon reductions that could or may not come from those decisions. The next one is the BEAM tool, another free tool that's great at estimating embodied carbon across your buildings or portfolios. And you can use this for your policy or any benchmarking or sort of high level assessments. Again, this one can be used, I think, from SD to CA, but it is strictly A1 to A3, so it's important to note. The Kaleidoscope tool, I think, is really cool and really helpful to kind of visualize carbon impacts of kind of different designs across different, assembly scenarios, whether that's part of your enclosure, part of your floors, any sort of interior partitions. It's a really great way to kind of visualize each of the different options. The last one is C-Scale. This, I think, is probably the newest and maybe most exciting one coming to the stage right now. It's not included with the other tools I'll be mentioning in a second, strictly because it uses its own kind of proprietary calculations. So it's not technically LEED compliant at the moment, but it is capable of conducting A to C, we call A to C whole building life cycle assessment. So it is important to note, and is definitely available for free at the moment for practitioners. Next slide, please. So here's the run through, I guess, of kind of the big three full whole building LCA modeling tools available. So I think the first one to mention, and what's I think probably the most popular, definitely most comprehensive, and is widely used in Europe and is starting to be used more readily here in the US, the one-click LCA tool. I'll kind of run through some of the differences between the tools, but basically one things to note, I guess, for one-click is that it is definitely the most expensive tool. So it's around $5,000 per seat. So that's important to note. There is BIM integration, which is great for, projects that are running in Revit. And then there's, it's important to know that it's easy to manipulate the model. So what that means, you can kind of put in your own EPDs into the model and understand, the differences between industry average products and specific products with EPDs available. And I think the most important thing to note specifically about the one-click LCA tool is that what it does is it puts the responsibility to create the model directly on the user, but it does allow the user to complete the calculations. So that's a little bit different from the Tally tool. I'd say this one is probably the easiest tool for practitioners to use and kind of get started in. It's really well integrated within Revit. It's a little bit less expensive. It's around $1,000 per seat. I'd say the biggest differences between this tool and one-click is that it's kind of difficult to manipulate the model and use other APD inputs. You can do that on your own, but again, it kind of takes a little bit more practice and a little bit more experience with the tool itself to understand how to do that. And so again, kind of what that difference between Tally and one-click is that Tally takes a lot of the modeling responsibility away from the user and the modeler, and allows you to kind of, again, easily get into it. There is a new version coming out that should allow the users to put in more, product specific EPDs into their models and do those comparisons. But until then, this is kind of where the scene lies at the moment. The last one I'll mention is the Athena Impact Estimator. This one is free. There is no BIM integration. It's kind of difficult or impossible to input any external EPD data into the models. And then there's pre-built design scenarios that make it easy to create a model. And it basically takes almost all the modeling responsibility away from the user and the modeler. So I'd say these are the big three, but OneClick and Tally are basically the most used tools at the moment. Next slide, please. So where do all these tools kind of lie in terms of the whole building LCA modeling workflow? So from schematic design through CA, a lot of these tools that I mentioned that are free, with Care, Epic, Kaleidoscope is that kind of funny graphic there below Epic, the Beam tool, those and C-Scale, those can all be used in schematic design, again, to kind of understand, maybe different design scenarios or different building scenarios. And then, as you move through DD, you kind of understand those design scenarios that you're looking at. Maybe there's different assemblies that you can start, understanding the different reduction opportunities associated with each of those. And then moving through construction documents, that's when you can start to really use your OneClick LCA, your Tally tools to kind of understand that full kind of embodied carbon assessment through design, through like 100% CDs. And then through the project procurement process, this is kind of just understanding, collecting all of the data around the materials that you're using on your project, getting product specific EPDs for all of those materials, or all, but at least the relevant materials, and then finally conducting that embodied carbon reduction, that full as-built embodied carbon reduction, which I'd say is probably the most important piece that we want to get into in the next slide in a second. And currently, the only tool that can do that is the OneClick LCA tool. So that's that is the only one that can do that at the moment. Tally, I believe the new version of Tally will be able to do that. So that is important to note. Once the next slide comes up, I'll just kind of run through.
So sorry, just give me 1 second.
Yep, no problem.
In the meanwhile, folks, feel free to drop in your questions in the chat. We'll try and answer them simultaneously. Yeah.
Yep. Okay, here we are. Sorry about that, Jacob.
That's okay. Just don't want to run over time.
No, you're good.
Yeah. So just quickly kind of understanding how to work with whole building LCA modelers, whether that's in-house or whether you've designed, or whether you've have a consultant working with you on your projects. So first thing is first, I think the most important thing that you need to conduct an LCA is your bill of materials. So this is basically required at each stage in order to kind of analyze the embodied carbon impact at each stage, whether that's at SD. DDs is probably the earliest stage where you really have a more accurate bill of materials, and then obviously 100% CDs. And at the as-built model, that's where you're going to kind of update that with what is actually being built in your buildings. And it's also important to kind of understand the expectations for reductions, and especially at which stage, right? So early in design, thinking specifically, comparatively to operational carbon. Obviously, at the earlier you can start looking at reductions and opportunities for reductions. This is when you're going to kind of have more useful, targets. You're going to have greater opportunities for reductions. But the result at this stage, your SD model, your DD model is going to be a little less accurate, right? And then you move into CDs, and the opportunities for reductions aren't as great. And so you won't really have as much, as many reductions, I guess, if you target reductions at this stage, but your analysis and your results are going to be more accurate, specifically in CDs and during construction or as-built. The last thing I just want to hit on before I say goodbye and on to the next person is that the as-built models are going to be the most accurate and are definitely the most important in terms of, constructing your whole building LCA models. Those are the ones that you want to be putting time and effort into and creating, because that's going to reflect a really accurate result for your models. So with that, I'm handing it off to Patrick, who's going to talk through some embodied carbon reductions.
Great, thanks, Jacob. Yeah, Patrick Kenny from Thornton Thomas Study. I'm a structural engineer, so I'm going to walk you through really briefly what either the structural engineers on the call can do to make some reductions or what architects can do working with their structural engineers. Go ahead to the first one. So this can seem like a really complicated process when you first come across it, but I always like to reiterate that this is measuring embodied carbon in your structure is very similar to just measuring the weight of a building. You have a quantity of materials, tons of steel or cubic yards of concrete, and you're instead of multiplying it by a density, like 150 pounds per cubic foot, you're multiplying it by a carbon intensity, a GWP, and there have been a lot of great resources earlier in the presentation about where to find typical GWPs. So we know how to get a quantity, we multiply it by these sort of industry average values, and we can get the embodied carbon of our structures. So if you click one time, to look at how you might start reducing, I like to bring up a specific example. This might be a 4,000 PSI flat concrete floor slab. Just picture a big floor slab. It's 100 cubic yards of concrete. And maybe each of those cubic yards of concrete, you look up and that is about 300 kilograms of CO2. This is a typical value you might see. So the total embodied carbon of that slab is about 30,000 kilograms. So if you want to reduce that, you might start with the material side. So if you click one more time, you look at that 300 number and click again, please. And you might ask yourself, can I get concrete that's less than 300 kilograms a cubic yard? So that's sort of the first stop is, can we look at the material and do any better than this? Next slide, please. So the answer is yes. In concrete, most of the embodied carbon is coming from the cement. So the first stop on reducing your embodied carbon is using less cement in your concrete. So the picture here is lots of different cement replacements. Fly ash and slag are going to be the most familiar. We've also started using things like glass pozzolan to replace some of the cement. But if you take a quick look at the chart, replacing higher and higher percentages of your cement with these products is going to yield very significant reductions in your GWP. So this is our best current strategy, is trying to use mixes with as high amounts of cement replacement as possible. Let's click one more time. Next slide. So the other way we can manipulate the amount of cement in our mix is changing the strength of our concrete. So roughly, the cement content is going to scale with strength as we go from 4,000 to 5,000 to 6,000 PSI concrete. You're using more cement in every cubic yard, so your embodied carbon is going up. And just as a plug, these values all come from the SE 2050 site. They have what's called an ECOM, an embodied carbon estimator. Great first stop for structural engineers. This has some really good average value GWPs, and you can just punch in your quantity and get an outcome. So if you click one time, what you might look at here, sorry, one more time, is that if your baseline is 4,000 PSI concrete, as you get those higher strengths, your embodied carbon is going up 20, 30, 40%. And if you were to scale down those numbers, it's reducing. This doesn't always mean use lower strength concrete. It means that this is a lever we can pull. We can either use higher strength or lower strength and manipulate the quantities. This is something your structural engineer can use to try to optimize for carbon. Can go to the next slide. So we can come back to this basic equation. We looked at that 300 number and click one more time. The other thing we can do is look at the material quantity. So do we actually need 100 cubic yards of concrete? How might we manipulate that number? And if you click one last time, right, can I use less than 100 cubic yards? And one more time, sorry for all the animations. I'm usually the one clicking through these slides. You can look at those two things together, the quantity and the material intensity, and try to optimize. So you might ask yourself, could I use 80 cubic yards of 6,000 PSI instead of 100 cubic yards of 4,000 PSI? Or change the whole system from concrete to steel and see what combination of materials and intensity gets you the lowest carbon solution. One more time, please. Right. So when you're trying to look at reductions, the first step might be, where should I look? I could do this kind of exercise on any piece of structure in my building. It's important to know where to focus. So this is a good study that was done with several hundred structural projects. And what we did was we looked at, on average, where's the highest percentage of the carbon. So as you can see here, the dashed line is the average. Our two biggest heavy hitters are floors and foundations. So if you're going to focus on one spot, it's zoom in on the floor or zoom in on the foundation and try to do some of these exercises. All right, next slide, please. So this will be familiar to structural engineers, but on the efficiency side, something as simple as bay size. As you get your columns closer together, you're going to shrink your slabs and beams and drastically reduce the quantity of structural material you're using. But structural engineers will be familiar with many different ways to increase efficiency. Let's go to the next one. And then there's material selection, this optimization question. If I look at different combinations of things, steel and composite slabs, or concrete cast in place, or precast, this is one building that it was designed with 8 different structural systems, and the number there is the embodied carbon per square meter of floor area. This is not a rule that this will always follow this pattern of which one is high and low, but it just means your embodied carbon is going to vary a ton based on what system you select. So studying a few different systems early on is going to be a great tool to make reductions. And next slide, please. And as a last plug, what we didn't talk about was you can use material besides steel and concrete. And a great one with a much lower carbon footprint is timber. So there was a mass timber accelerator program put on between 2021 and 2024. That was a partnership between the BSA and the BPDA, which took a bunch of local projects and studied whether or not they could be done out of mass timber. I participated in this program. It was great. It connected project teams with timber experts. And the outcomes of that were that there were a lot of benefits to using mass timber on these projects. You could get really efficient floor-to-floor heights with it, with a nice low-profile cross-laminated timber slab. It reduced building weight, which is especially beneficial if you have challenging foundation considerations. You could reduce your foundation quantities. Obviously, a reduction in embodied carbon on any projects that are looking to get aggressive reductions. It's a beautiful material. It's biophilic. I'll add to this one thing that my project studied was it's a market differentiator. These buildings look a lot different. So developers are often interested in the premiums they could get for apartments or office spaces that are just very different than the rest of the market. It's also very fast on the erection time. It's one of the fastest materials to erect that we have. So it can really help construction time as well. With that, I will pass it off to Olivia for the last section.
Hi, everyone. I'm Olivia Huang. I am an architect at Goody Clancy, and I also co-chair the Carbon Leadership Forum Boston's Deconstruction and Reuse Working Group. We have monthly meetings, and our meeting this month is actually Friday at 1 p.m. It's virtual on Zoom, so reach out to that email if you want to join. We'll be getting a presentation on a reuse interior renovation case study this month. Next. So deconstruction and reuse not only have benefits for embodied carbon, but other environmental benefits as well, from virgin material demand reduction. It deals with our waste problem and how we're running out of landfill space. It supports regional economies and workforce development. It's an environmental justice issue. It reduces extraction of materials at vulnerable communities, and demolition causes a lot of pollution. So deconstruction is a healthier alternative to that for communities. And I also think deconstruction and reuse are just creative and beautiful. They are ways for us to find new ways of working with materials that we haven't done in our design process so far. Next. So first, I'm going to advocate for building reuse. If you reuse a building, you're going to use way less carbon than new construction. These are snips from the Embodied Carbon Benchmark report that some people are talking about in the chat, which looks at multiple buildings across North America. So you can see here that renovations on the whole will be less carbon than new construction. Next. And this from the benchmarking study as well is showing that structure, as you just learned, is a large amount of the carbon in buildings as well as the enclosure. So those are the areas that you need to report on and have the highest impact. But I will also make a plug that the interiors, next, have a major impact. So if you're reusing your building, then interiors are where you have agency in reducing carbon. Interior finishes are also the ones that are most likely to be refreshed every 10 years, say. So once you're renovating a building and updating the interiors over and over, those add up quickly in terms of carbon. And where reuse comes in, next. A lot of the materials that are easily deconstructed and reused today do contribute to those interior finishes. So furniture, equipment, appliances, millwork, fixtures. And I'll share some strategies that you can use for whether reuse works for your project and how you can apply it. So some opportunities are if you have any of these commonly salvageable materials. If you have a lot of them, that is an opportunity. If they're valuable, such as stone or marble, or they have historic or cultural value, things that we don't make anymore, things that are really stylistic of their time. These photos are from a project that E. Clancy did at Cornell University. And we saw an opportunity where we were renovating this dorm and it had hundreds and hundreds of solid, beautiful solid wood doors. They were not able to be reused as doors due to code because they were too small for what we would use today, but we repurposed them into wood wall paneling. And so cut out devices and hung AV. And we also retrofitted a bunch of light fixtures to keep the character of the building within the renovation. Next. Some design strategies for reuse. Ideally, you reuse materials for the highest and best use. So you keep the structure as structural materials. You salvage some doors as doors. But knowing that you can't always do that, you can downcycle them into things that require lower performance. So an example would be exterior windows that wouldn't meet performance today, but you can reuse them as interior glazing as borrowed lights. Another strategy I like is to do reuse in back of house spaces. Sometimes clients are concerned about how it will look, whether it matches the aesthetic of the rest of the design, but there are a lot of spaces in our projects where those aesthetics are not as much of a concern, or matching everything is not as much of a concern. So use it for the bathrooms or the mechanical spaces. I show another case study Goody Clancy did, which is here in Massachusetts. And we had a lot of this perforated metal material shown on the top. And we saw that as an opportunity to upcycle it into feature wall paneling in our main design space. Next. And I'll talk through some resources that are available and out there for getting your feet wet into deconstruction reuse. The first, the Boston Reuse Group put out this reuse roadmap, and it breaks out the best practice strategies by role. So if you're a designer, where is your agency? If you're a contractor, how can you impact? And spells it out for policymakers, owners, and developers, and also innovation groups, like if you're in research or consulting. So that's a great guide. And then the next guide is a favorite of mine because it really gets into implementation. It talks a lot about the design process, what decisions to make when, and it has handy templates for doing a site assessment. So walking through the site, seeing what you have, what condition are they in, and what could you possibly reuse them for. It has example specification language for sourcing from reclaimed vendors or for salvaging and reusing on site. And it has additional case studies, which are always inspiring. That's it from me. Thank you.
Great, thank you very much. First, I would like to say a big thank you to all of our great presenters for this engaging, lots of information. I know it can be overwhelming, but as we said earlier, we're going to share all the slides with the links so you can go through them and access all the resources that was shared. And you can also, Harshika again posted the AIA CE credit link that you can go and apply for your credit. So there were lots of great questions. Thank you for the engaged audience. But thankfully, all the presenters responded those. So now, since we have like about 10 minutes, I was hoping that we can open the floor, and people who have questions they want to ask, maybe they can use the raise hand icon, and they can, we can choose and they can ask the questions if there is anything that you want to discuss. Okay, so if I don't see any raise hand, Anna, Juhi, do you see any raise hands? No. Okay. Great. So Harshika and Jessica, if you are fine, and we can just close out and finish the presentation.
Sure. Maybe we can put in our emails in the chat in case people have questions.
Yeah, we actually shared the emails all on the screen, and
Okay,
the reason is if they have questions, they can reach out. And just another item is tomorrow from 6 to 8 p.m. at Trillium Garden on the Greenway, CLF has their summer social events. So you're welcome to join, and we'll be happy to see you in person there. And Anna just posted the link to the event.
And
Thank you very much.
I just wanted to also let everybody know that the BSA right now is going through their own internal and external changes. They're looking for a new home. And so all of the knowledge communities, their events have been put on hold until the fall. So if you go to the BSA website and see fewer events available, that's the reason why. So anything that's in the pipeline and has already been planned will go on, and then otherwise we will see you back in the fall.
Thank you all.
Thank you, everyone.
Thanks, everyone, for joining in.
Yeah, thank you so much.
Bye.